welcome back. Monty here. We're on week 34, May 24th to the 28th, and we're on our Wednesday, Thursday. We're going to wrap up circles, volume, surface area today. Okay? So, the other day, we took the universal tool, paper towel and toilet paper roll. Last week was all about the circle. Then on Monday, Tuesday, we capped it and we calculated volume of three-dimensional objects. Today, we want to open this up and calculate surface area. How much stuff does it take when we open this? What is the surface area of an object? Okay, so Monday, Tuesday, we went through and we created volume, we created a three-dimensional shape, and then we used this formula, pi r squared h. We went and saw a video and we learned about what makes a three-dimensional can, and then we watched another video on how many of these cones fit inside the cylinder, and it turned out to be 3 of them. So the formula was 1/3 pi r squared h. Now today, surface area. Surface area? Well, that's not that big a deal. We know surface area, and some of you back in middle school may have studied what was called nets. Okay, so we got a cube, right? We got this box here in this problem, a 4 by 7 by 3. Well, to create a net, we just pop out the innards here. Easy for me to say. And the surface area of a box is all the sides. And we know how to calculate the area of one of these little pieces. Length times width, length times width, length times width. And then we add them all together, right? So let's just do that. Determine the total surface area of the right prism. Now, isn't that a fancy term for a cube, for a box, for a tissue, right? Just take some sort of a box. They call it a right prism. See? Math is fun until you get the vocabulary involved. Okay. Well, we know how to do this. Be sure to label the single label on each side, the regular polygons. Okay, so here's the actual formula. The surface area, the length times the width. So let's just label this real quick. Length and width. There's an end. Okay, so the end is length times width. And there's an end, right? So the end is length times width. Height times width. The bottom, the top. Okay? So that's the ends, bottom and the top, and length times height. We got the front and we got the back, right? So we have what? A front and a back. And because we know it's a right prism, that means we can just double them, because the front and the back are the same, the ends are the same, top and bottoms are the same. That's where 2 of the ends, top and bottom, there's 2, front and back 2. Okay, so let's just make a list. This particular problem is surface area. Okay, so 3 and 7, the bottom and the top. There's 2 of those, 3 times 7, plus, let's do the ends. The end and the end, 3 times 4, and there's 2 of those, 3 times 4, front and back. We got the front and the back, 4 times 7, plus 2, 4 times 7. Okay, so what do we got? 21, 2 times 21, 2 times 12, 2 times 28, 42, 24, 56. Not even going to try. 42, clear. 42 plus 56 plus 24. 122. 122 square units. This doesn't say units, so we're going to go square units. 122 square units. Okay? Alright. Now, most of you remember some of this stuff from middle school, length times width, and you just got to find all the pieces, right? Okay, a net. Some of you remember net, some of you don't. No problem. Now, the next one, pause the video, everybody try it on your own, and then come on back where we can chat about it. Talk to you soon. Surface area. Okay, now, partial credit. The surface area. We got a bottom. We got an end. We got an end. We got a back. Okay. Kind of messy looking if you ask me. Alright, now, the ends are the same. The bottom, okay, let's do the bottom. The bottom's easy. And the bottom is just 8 times 9. The back is easy. 6 times 6 times 9. 6 times 9. 6 times 9. Okay, now these ends. The ends are 2 triangles plus the top. And this top, we need this length, don't we? Top is 9 times that green line right there. We got to calculate the green line. Everybody remember how to calculate? Come on now. We can do this. This triangle. It's a right triangle. If this is 6 and this is 8, how do we find the hypotenuse? Come on. That guy's name is Pythagoras. What did Pythagoras say? Something squared plus something squared equals something squared. Okay, so this length right here is 6 squared plus 8 squared, and we have to take the square root. That's the question mark. Okay, so this is going to be 9 times the hypotenuse. 6 squared plus 8 squared. Okay, have to do that math. Okay, now triangles. Come on. We're putting everything together. We're at the end of the year. We've got to have all these skills. How do we calculate the area of a triangle? Come on now. We've done this. Remember this famous prop? The area of a box is length times width. But we need the area of a triangle. How do we calculate area of a triangle? I know some of you know. Come on. Length times width divided by 2. Length times width divided by 2. So, we can use this again, right? So the area is length times width divided by 2. The area of this triangle is length times width divided by 2. 48 divided by 2 is 24 units. So we have 24 units in the front, 24 units in the, excuse me, this end is 24 units, this end is 24 units. So this is 2 times that 24 plus 9 times whatever that was, and we have 8 times 9. Okay, so let's put it all together. 72 plus 54 plus 2 times this plus 9 times this. Okay, this is 36 plus 64. 36 plus 64 is the square root of 100. I'll bet you somebody in the room knows what 9 times, or the square root of 100 is. 9 times 10. Right? Let's do that up here. Square root of 36 plus 64. The square root of 100 is 10. Good. Okay, so now 9 times 10, which gives us 90. Let's grab our calculator. We're putting everything from the entire year in this problem. Isn't that exciting? And it's real world. 72 plus 54 plus 48. 2 times 24 is 48 plus the 90. 264. 264 square inches. Okay. Pause the video, have a little discussion. Okay? Because the rest of class, have your discussion. Make sure everybody understands how this unfolded to get the net for surface area, because this is the only one we're actually doing. Alright, welcome back. The rest of class is for fun. We need to calculate the surface area of your object, of your paper towel roll, of your toilet paper roll. So now, everybody, pause the video. Go get your universal tool for this geometry topic, the toilet paper roll. Everybody go grab yours, come back to your seat, and I think Mr. Miller is going to be giving out scissors because we want you to slice them. Okay? See you soon. Alright, welcome back. I think this is the time of year when we're supposed to enjoy ourselves and have a little bit of fun. Okay? So we've got 3 videos here. Actually, we have 3 demonstrations here. Okay? The first one is, what does it mean to calculate the surface area of a cylinder? How do we do that? Then, this demonstration about how you unfold a cylinder in order to get the surface area. So, we've got our cylinder here. We pull out the guts, and it turns out our net looks like this. Okay, and then, depending on time in class, Mr. Miller will actually show this one, but he'll demonstrate it with the slider tool. Okay, alright, then we're just going to actually calculate this. Alright, so let's get started. So the first thing we do is click right here. Little YouTube video.
Grammarly does more than catch errors. With Grammarly, you can find really...
In this video, I'm going to discuss how to calculate the surface area of a cylinder. For a cylinder, you have the top, you have the bottom, and you have the side. It turns out, when you unwrap the cylinder, the side is just a rectangle, the top is just a circle, the bottom is another circle, adding the area of these 3 objects will give us the surface area of a cylinder. The only tricky part is the length of the rectangle. It turns out, if I wrap this back around, you can easily see that the length of the rectangle is the circumference of the circle of the top of the cylinder. Again, the length is just the circumference of a circle, which is 2 pi r, where r is just the radius of the cylinder. The area of each circle is pi r squared, where r is the radius of the cylinder, and the area of the rectangle is height times 2 pi r. Adding the area of these three objects gives us the surface area of a cylinder. I'm going to leave it at that, and I'm not going to try to simplify the equation. There's a lot of different ways to write the equation, but I'm just going to leave it in this form. I did mention it, but r is the radius of the cylinder, represented by just r in that black line there. And that should do it.
Okay, now a different way to look at it. We'll go to GeoGebra.
In this video, we're going to talk about how to calculate the volume and the surface area of a triangular prism. But first, let's draw a picture. My picture's not perfect, but you can see what I'm trying to draw. And let's draw a rectangular prism. Now, if you recall, maybe from a previous video, that the volume of a rectangular prism is the length times the width times the height. Now, look at the triangular prism. Notice that it's half of a rectangular prism. Let me draw it inside the rectangular prism in blue.
Okay, so hopefully that was helpful. Now, in class, go ahead and pause this video and actually go to GeoGebra.
You can see it's about half of the volume of the
Whoopsie. Okay, now, in class, if you want, Mr. Miller and you folks can actually do this slower, okay, and get a better feel for it. All right, for this video, I want to make sure that everybody actually takes your toilet paper roll, just slit it. Before you slit it, make sure you know what the circumference is. Because remember what they said. The circumference, right, in the green over there, turns out to be the length. Okay, so when I slit this distance right here is 2 pi r. 2 pi r times h. Okay, so go ahead, grab your scissors, slit it. I'm just going to go down here and actually draw mine. Okay, so in my case, I started out with a toilet paper roll. Start out with a toilet paper roll. Yucky. A little bit better anyway. Right? Okay, now my toilet paper roll was 0.85 inches. My radius is 0.85 inches. So my circumference is 2 pi r, which is 2 times 0.85 times pi. I'm just going to keep it simple. 1.75 pi inches. Okay, that's my circumference. So when I slit this and I unfold it, fold this piece right here. No, don't do that. Don't do that. This piece right here is this piece. So my height, excuse me, this is my height, how tall it was. My circumference, my length is the circumference, which is 1.75 pi. Now, surface area is nothing more than length times width, where my length is 1.75 and my width, or my height on mine, was 4.5 inches. 4.5 inches. Okay? If I grab my calculator, 1.75 times 4.5, 7.875 square inches. Okay? So, using tools, okay, first I had to measure across, get the diameter, cut it in half. So that's where I got my 1.7. Then I got my length. Okay? Get my length. That's where I got my 4.5. So 4.5, half the diameter, 0.85, and I have the surface area of the universal tool for three-dimensional shapes, the paper towel roll or the toilet paper roll, depending on what you use. I hope you all enjoyed the last 3 weeks of three-dimensional shapes. Okay? Don't forget you got a solo activity. Don't forget to clean up the room. Help Mr. Miller because we use scissors and we got to wipe everything down. If you want, feel free to hang them back on the wall because it's fun to see all the stuff that we've created. Otherwise, take it home and put it in your hope chest. 20 years from now, you can show your kids the universal tool for three-dimensional shapes. See y'all on Friday. Bye.